A radian is an exact measure whenever the arc length along the outside is equal to the radius. And we saw that with the equilateral triangle that I had the other day, that if you took an equilateral triangle with all 60-degree sides or angles and all sides the same, if you bent the one side so that it replicated the arc of a circle, that would squish this angle a little bit, making it a little bit less than 60. What we're going to find out today is what is it exactly? How do we find that value exactly? And we saw the other day that if we split up and counted how many of these equal parts were around the circle, we got 6 and a bit. That's just an estimate by counting them, by looking at them. But then if we think about it a little bit further and say, well, I know that there's 360 degrees in a circle, and I know that my circumference of my circle is 2 pi r. This is one with a radius of 1, but this is true if you have a radius of r, your circumference, and I'm going to put that 2 pi in brackets because what that formula is actually telling us is how many radiuses fit around the edge of a circle, around the perimeter of the circle. You need 2 pi of them, which is approximately 6 and a bit, 6.28. And so if we need 6.28 radiuses to go around the circle, or 2 pi radiuses to go around the circle, that means that in one full circle, there's 2 pi radians. Using that idea and moving forward, we can now say, well, I'm going to use degrees first. 360 degrees is equal to 2 pi radians. So if 360 degrees is equal to 2 pi radians, how many degrees is pi radians? Yeah, 180. So in half a circle would be pi radians. Now, what did we do as we went from here to here? Right? I divided by 2, so I divided by 2 here. This is just common ratios and common ideas of when things are equal but have different measurements, we can work with them. And from this, well, we could work a little bit further, and I could say, what's 1 radian? What would I have to do to the left-hand side here to make these equal? How do I move from here to here? I need to divide by pi. So on this side, 1 radian, I would divide by pi on this side as well to get there. And I find out that 1 radian is 180 over pi. If we type that into our calculator, 180 divided by pi, then we get 57.3 degrees, which a little bit less than 60, what we thought before. So this is going to be one important expression that we're going to use. That if we know what 1 radian is, now we have the ability to find out 2 radians by just doubling it. We could find out what 5 radians is by multiplying both sides by 5. We could find out what pi over 10 radians is by multiplying both sides by pi over 10. Another important thing, because we're going to be asked to switch back and forth between radians and degrees often, is to figure out, well, if I know what 1 radian is, can I figure out what 1 degree is? Well, what would I have to do to go from 180 to 1? I'd have to divide by 180. So the same thing here. Well, Radians. That 1 degree will be pi over 180 radians. Now, those formulas are very similar. If you try to memorize them directly, you're going to mix them up. But if you start off by just knowing this fact, there's 2 pi radians in the circle. There's 360 degrees in the circle. You probably don't have to memorize that. You probably know that already. Then you can just figure this out, right? 360 is 2 pi. That means pi radians is 180 degrees. Right? We never say pi is 180. Okay, we have to be careful with our language because pi is 3.14. That's never changing. And if I say pi is 180, that's not true. 3.14 does not equal 180. But pi radians is equal to 180 degrees. That's a true statement. It's like saying, is 1 equal to 12? No. But 1 foot is equal to 12 inches. That's a true statement. As soon as we put a measurement in there, right? Is 80 cents equal to $1? If you say yes, then I'll give you 80 cents, you give me $1, and we'll keep doing this for a long time until you decide you want to stop. But 80 cents American right now is worth 1 Canadian dollar. So there's a place where it's the same. And if you get that mixed up and you want to trade me 1 American dollar for 80 Canadian cents, we'll do that for a while too, until you decide to stop. But the units are important. Pi radians is 180 degrees. And if you have that, you could divide both sides by pi to find out what 1 radian is. Or divide both sides by 180 to find out what 1 degree is. And once you have these things in the red boxes, they allow you to convert any amount from radians to degrees or degrees to radians. Now on the top of your next page, they have this big shaded box. I'll erase some stuff here. In this big shaded box, they have some of these key facts again. So they have the 1 degree is pi over 180 radians, and they have 1 radian is 180 degrees over pi. And where do we get those from? Starting with this and then leading to this. Now, in the space that you have right beside this, we're going to write some additional notes dealing with arc length. We're going to start with what we did in 6.2 was we developed a formula for arc length in degrees. That formula that we developed, again, we're going to look at it same as our formula sheet. The textbooks uses a little a. Your formula sheet uses an S for arc length. And we figured out that all arc length was a percentage. Theta out of 360 will give you a percentage of the whole circumference. So we left our formula like this from 6.2 because it really makes sense. This is just a portion of, or a percentage of, the whole circumference. And theta out of 360 is your percentage, and then there you have your whole circumference. Now, we can do the same thing with radians. The idea stays the same, but instead of having your angles in degrees, you have your angle in radians. So again, you have your proportion, but instead of being out of 360 degrees, it would be out of 2 pi radians. And if you wonder, do I have to write the word radians every time? No. Is there a symbol for radians like there's a symbol for degrees? No. Whenever you write an angle and you leave no symbols on it, it's assumed it's radians. So every time in grade 9 you were lazy while doing circle questions and just wrote 45 and didn't write the degree sign, you technically wrote 45 radians. And 45 radians is like 9 times around the circle almost. It's like, or not, 8 times around the circle. That's a really different angle. So just missing that, but you didn't know. You're just like, the only thing I know is degrees, so when I write it, that's what I mean. But now that you learn radians, every time you forget that degree sign, you're talking radians. And you don't have to write any symbols. So there's our percentage. There's our portion of the whole circle, of your whole circumference, and your circumference stays the same. Now, this formula in particular is just so tempting to simplify that you're going to simplify it. Because watch, if I make this a fraction over 1, can you see that those 2 pi's just cancel right out? And this becomes a really simplistic and elegant formula. And this is what shows up on your formula sheet. S is equal to theta r. Now this formula only works if it's in radians, because it only simplifies if it's in radians. But all we need to do is take our angle, multiply it by our radius, and we'll figure out what the length of the arc is. The first thing we really need to practice is switching between radians and degrees. So if you turn to example 1, we've got an angle theta in 170 degrees, and they want us to determine its measure in radians. So we need to know what 1 degree is, and 1 degree is, and I'll write the word radians for a while here just to get us used to it. Eventually you wouldn't need to write that because there's no symbol for radians. But 1 degree is pi over 180 radians. So then if I wanted to figure out what 170 degrees is, I would have to take 1 degree and multiply it by 170 degrees. I would have to do the same here and multiply this side by 170. If I do that, there's no degree sign, sorry. If I multiply both sides by 170, I get 170 pi over 180. And you can reduce that fraction. Maybe you can see in the numbers it could be reduced to 17 over 18. But you don't have to reduce your fractions in grade 12. You could leave your answer 170 pi over 180. So there's no deduction for an unsimplified fraction if it's not in lowest terms. That'll be fine. So relatively straightforward to change it to an exact value. If we wanted to find out as an approximation, we'd have to go to our calculator, type it in, and we find out that to the nearest hundredth, that 170 degrees is approximately 2.97 radians. And this is where radians are going to be difficult for you at the beginning. Because if you think of 170 degrees, you probably have a picture of how big that angle is. If you think of 2.97 radians, you probably don't have a picture yet of what that means. So what we need to do is to give you lots of experience playing with radians, measuring with radians, thinking about radians, so that you get a working knowledge of what they mean. So you can imagine 2.97 radiuses around the edge of a circle. Maybe that helps you imagine that angle. Probably not yet. So again, we'll do a bunch of activities and questions that get you used to working with radians. Part B, now we have something in radians. We have negative 12 pi radians. We want to sketch that angle in standard position. So you could change it to degrees first and then sketch your angle in degrees because you're more comfortable with that. But we want to get used to working with radians directly. We don't want to translate it first to degrees and then figure it out. We want to think about using radians directly. And in order to do that, we have to think about your circle, or once around, in radians. You know that in standard position you start here at 0 degrees, that would be 0 radians. If you went all the way around, that would be 360 degrees or 2 pi radians. So since there's 2 pi radians in a circle, all the way around would be 2 pi. halfway around would be pi. And half of pi, we're going to write this as pi over 2. So 90 degrees is the same as half of pi. And 270 degrees down here, well, that's 390 degrees, so it's going to be 3 pi over 2s, or 3 pi over 2. So now we're thinking about sketching negative 12 pi over 11. First of all, if you just think about the fraction in front, negative 12 over 11, can you see that that's more than 1? Negative 12 over 11 is like 1 and 1/11. A little bit more than 1. So if we want to go negative 12 pi over 11, for 1, you're going to be going in the negative direction. Does it make sense up to here that this would be 1 pi? And we want to go negative 1 and 1/11 pi. So we're going to go past here, and I'm going to imagine this next section split up into 11 equal parts. And then I can label negative 12 pi over 11. So we're thinking in terms of pi being halfway around the circle. And I'm going negative 1 and 1/11, so I'm going to go a little bit more than halfway, and 1/11 more. That's going to be the measure of negative 12 pi over 11. So now that we've sketched it, now we're going to convert it. So what does that mean? Well, we know that 1 radian is equal to 180 over pi degrees. So if I want to find out what negative 12 pi over 11 radians is equal to, I would have to multiply this side by negative 12 pi over 11. And if I multiply this side by negative 12 pi over 11, I'm going to need to multiply this side by negative 12 pi over 11. And something nice happens on the right side. The pi's cancel out. We go to our calculator. 180 times 12 is 2160. And so you could leave your answer as negative 2,160 over 11. It does say round your answer to the nearest tenth, so I will take that number and divide it. And I get negative 196.4. Again, make sure that that degree sign is there, because we're dealing with degrees. It needs the degree sign. Does our angle that we originally drew look like negative 196 degrees? Yes, a little bit more than 180, 16 degrees more. That looks about right. So again, once we know what 1 radian or 1 degree is, we can use that to figure out any angle. With changing from radians to degrees, there is a shortcut if your original angle in radians has pi in it. So if you want a shortcut for changing from radians to degrees and your original angle has pi in it, you can just change pi to 180 degrees. Notice that that's what happened over here. If we look at our algebra, when we multiplied by negative 12 pi over 11, our pi's canceled out, and we were just left with 180 instead of the pi. And since pi is equal to 180 degrees, this is what we can do as a shortcut whenever we have 180 degrees and pi. Question C, we want to change 7.5 radians to the nearest degree. Well, we know that 1 radian is equal to 180 over pi degrees. Okay? Sometimes if you're thinking about it, if you're trying to go to the ratio directly, another way that can help you remember is remember that 1 degree is just a little bit less than 60. pi is very close to 3. It's 3.14. Can you see if you do 180 divided by 3, you're close to 60. You are, well, 180 divided by 3 is 60. But if you divide it by a little bit more, you'd be a little bit less than 60. So that might be another way that can help you remember what 1 radian is equal to 180 over pi degrees. I want to find 7.5 radians. In this case, there's no pi on this side. So if I want to find out what 7.5 radians is, I would need to multiply by 7.5. So I'm going to need to multiply this side by 7.5. I'll go to my calculator. And we get 429.7 degrees. Okay, questions for practice are 4, 5, and 7.